Hello. Today we're going to learn about in chapter 13-3 solving trig equations that are quadratic like they were in the last section of the chapter, but this time they're not going to be factorable. So right now we're on page 5 of our chapter 13 notes. And when you solve an unfactorable quadratic equation, you can use the quadratic formula to solve it, or you can do a complete the square if you'd like. Most people prefer quadratic formula. So what we're going to use is a quadratic formula on all these problems. And remember, with the quadratic formula, you always have two answers. You have negative b plus or minus the square root of b squared minus 4ac. So there's a plus and there's a minus, which gives you two results. And when we get the quadratic formula result, we're going to round that to 4 decimal places. And then after we round that to 4 decimal places, we're going to find angles of theta, not the x values. So don't stop when you've solved for x. You've got to go that one step further and find the theta value. So let's get into an example here. If you tried to factor this, 3 times negative 4 would give you negative 12. And there are no factors of negative 12 that add up to negative 5. So this is unfactorable. So we have to use the quadratic formula, which goes like this. X equals, we could sing, negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's the quadratic formula. And now we have to have a is 3, b is negative 5, c is negative 4. So when we plug those in, negative 5 is positive 5, plus or minus the square root of negative 5 squared is positive 25, minus 4 times 3 times negative 4, all over 2 times 3, which is 6. And you can leave it just like that if you want. Your calculator really doesn't care. But we have two x values here. We have an x equals 5 plus that whole thing over 6, and 5 minus that whole thing over 6. So let's pull our graphing calculators out. And let's get alpha y equals, let's get a fraction going here for our quadratic formula. So x equals 5. And we'll do the plus side of it now, plus the square root of b squared, which is 25 minus 4 times 3 times negative 4 all over 2 times 3. You can do 2 times 3 if you want, or you can just put a 6 down there. But there is your quadratic formula answer, and it turns out to be 2.2573. We have to round it to 4 decimal places. So 2.2573 would be one answer. And then the other answer you can get by just going up to your graphing calculator, or going up to your previous step. Whoops. Just hit your up arrow and highlight what you just put in and hit enter. And now you can just backspace and change the plus to a minus. And then you don't have to key in all of that other stuff, and you get negative 0.5907. This 6 rounds it up to a 7. So this is our other x value, negative 0.5907. Remember, it's 4 decimal places that we need. So we would be done with that problem. Now what we're going to do is solve the trig equation that looks just like that one. If we let x equal the cosine of theta, then what we have is 3x squared minus 5x minus 4 equals 0. And that's exactly what we did back here. So we're not going to go through all of this work again, because it would be the same exact work. But now instead of x, we're going to have cosine of theta equaling 2.2573 in our t table, and cosine of theta equaling negative 0.5907. Well, those are strange numbers. We're going to take our calculator, make sure the mode is in degree mode, and we're going to do a second cos of that number. So second cos, And what I can actually do and make it a lot easier is I can just pop I can highlight that old value that I've just put in. So second cosine of that number, and it can be rounded or it doesn't have to be. And when you hit enter, you're going to get an error because you just put an X here. This is an error because the cosine of theta must be between -1 and +1. 2.257 is too big. Too big. So there's no answer on this side. Now over here, we're going to do, we'll quit out of that, and now we're going to do a second cosine in our calculator of positive. I'm going to write that down because everybody forgets to put a positive in there. Second cosine of positive 0.5907 will give you the reference angle. And so the reference angle, let's round this to the nearest degree, it says. So that would be 54 degrees. That's the reference angle. So we have a negative cosine here, and when we do all students take chemistry, cosine goes negative in quadrants 2 and 3. So we have a quadrant 2 answer, and we have a quadrant 3 answer. So what is our quadrant 2 answer? Theta is equal to 180 minus 54, the reference angle, and 180 minus 54 is 126 degrees. So there's one answer. And in quadrant 3, the theta value is 180 plus 54. And 180 plus 54, I think, is 234. Yes, 234 degrees. So this question has actually two answers. Sometimes we have 4, sometimes we have 2, sometimes we don't have any answers if both of these are outside the range. So now we're going to again round it to the nearest degree. We're going to let x equal the cosine of theta here. And what we're going to solve is 4x squared minus 2x minus 3 equals 0. Well, this is unfactorable, so the quadratic formula goes x equals negative b plus or minus the square root of b squared, which is 4, minus 4 times a times c is negative 3, all over 2 times 4, which is 8. And we're going to have two values here. I think I'll put it like this, one value here and one value here. So follow this along with your calculator. Put it in the fraction button. So x equals 2. We'll do the plus the square root of b squared minus 4 times negative 3 all over 2 times 4, which is 8. So there's one answer, 1.1514. And over here, we can just change the plus, backspace over top of that, and change the plus to a minus, and we get negative 0.6514. So now what we're going to do is, this is an x, this is a cosine of theta equals 1.1514. And the cosine of theta is equal to negative 0.6514. If we do a second cosine of that number, we'll get an error because we'll just put an x in here. This is an error because cosine of theta is greater than 1. It's too big. Can't be greater than 1. It can't be less than negative 1. So over here, we're going to do a second cosine of positive 0.6514 to give the reference angle. So second cos of 0.6514, that is a 49-degree angle. That's a reference angle. But when you do all students take chemistry, you should note that the cosine goes negative in quadrants 2 and 3, so you have a quadrant 2 answer and you have a quadrant 3 answer. So the quadrant 2 answer, theta is equal to 180 minus the reference angle. So 180 minus 49 is 131 degrees. So there's one answer. In quadrant 3, the theta value is 180 plus 49 degrees. So 180 plus 49 is 229. So now we have two answers to this problem, 131 and 229. Sometimes they're written in little squiggly brackets. If you want to, you can write it like this, 131 degrees and 229 degrees, if you like to put the little squiggles in. The next one is a tangent problem. So we're going to let x equal the tangent of theta. If you want to try any of these on your own, you're certainly welcome to shut the video off and try these on your own. Then turn it up again and see if you're right. This is 2x squared minus x minus 2 equals 0. It's unfactorable. So we let x equals negative 1 plus or minus the square root of negative 1 squared is 1 minus 4 times a times c is a negative 2. Be careful when c is negative or a is negative. All over 2 times 2, which is 4. All right, so we have two values of x we're going to figure out. Put it in fraction mode. X equals 1 plus the square root of 1 squared, which is 1, minus 4 times 2 times negative 2, all over 2 times 2, which is 4. All right, so we have 1.2808. And now we'll do the minus part of it, which is negative 0.7808. Now what we want to do is set up our t-table, which is a tangent of theta equals 1.2808, and tangent of theta is equal to negative 0.7808. So now we're going to find a reference angle, second tan of 1.2808. That gives us 52 degrees. Now remember, tangent can be anything. It doesn't have to be restricted between negative and positive 1. Tangent can be anything. So we have a reference angle which is equal to 52 degrees. And when we do all students take chemistry, tangent is positive in quadrants 1 and 4. So you have a quadrant 1 answer, or 3, and a quadrant 3 answer. So the quadrant 1 answer is the same thing as the reference angle. And the quadrant 3 answer is 180 plus 52 degrees, which is 232 degrees. So you have one theta value from quadrant 3 and one theta value from quadrant 1. Now over on the other side, we got to get a reference angle by doing second tan of positive 0.7808. And that reference angle is 38 degrees. So we'll write that down. The reference angle is 38 degrees. And now because tangent is negative, we have all students take chemistry tells us that our answers are going to come from quadrants 2 and 4. So in quadrant 2, the theta value is 180 minus 38. And 180 minus 38 is 142 degrees. And in quadrant 4, our theta value is 360 minus 38 degrees. And 360 minus 38 is 322 degrees. So in this problem, we have 4 answers, 52, 232, 142, and 322. Lots of answers, sometimes 4, sometimes 2, sometimes 1. Now this is going to be our last problem of this video. It says, on your own, solve for all values of theta. So it would be really great if you could shut the video off and try this one on your own. Or if you'd rather just watch me do it, you can. So let's let x equal the secant of theta. Now this might be a little bit trickier because it's a reciprocal. So this says 5x squared minus 2 equals 4x. So we have to set this equal to 0, so we have to subtract 4x from each side. And that's going to say 5x squared minus 4x minus 2 is equal to 0. Well, this is unfactorable. So x equals negative b plus or minus the square root of 4 squared is 16, so is negative 4 squared, 16, minus 4 times 5 times negative 2, all over 5 times 2, which is 10. So we'll have two answers to this. Let's see what we get. Put our fraction up there. And we've got 4 plus the square root of 16 minus 4 times 5 times negative 2 all over 2 times 5, which is 10. So it looks like we've got 1.1483. And now we're going to put the minus in. And we get negative 0.3483. Now that is the secant of theta equaling these. But remember, the secant is the reciprocal of the cosine. So when we take the reciprocal of this secant, we get the cosine. And the cosine is 1 over 1.1483, because we have to take the reciprocal of that. And the cosine of theta is equal to 1 over negative 0.3483. So remember to take the reciprocals when you have a reciprocal function. So let's get a reference angle now. Let's do second cos of this value right here. I'm not going to rewrite it again. So second cos of, I'll make that a fraction, 1 over 1.1483. So our reference angle is 29 degrees. And all students take chemistry tells us the cosine is a positive value in quadrants 1 and 4. So you have a quadrant 1 answer and you have a quadrant 4 answer. Well, the theta value is the same thing as the reference angle. So 29 degrees is one answer. In quadrant 4 you have 360 minus 29. 360 minus 29 is 331 degrees. So those are your two answers over on the left-hand side. Now over on the right, we're going to do second cos of the positive value of that. So it's just going to be 1 over 0.3483. So second cos of 1, oh, I guess I'll do a fraction. Second cos of 1 over 0.3483. Was that it? Yep. Make sure it's always a positive going into the second cos. And you're going to get an error out of this, because if you actually do 1 over that number, it's going to give you a number that is greater than 1. Like if I take this second cosine out of there and I just try to figure out what is this value right here? This value is actually 2.8710. So when you do second cosine of 2.8710, which is the same number as this, these are equal numbers, then you will get an error because cosine of theta is greater than 1, which is too big. It's got to be less than 1. So in this particular problem, you only have 2 answers, 29 degrees and 331. So this one, like I said, was a little tricky because we've got a secant, but all you have to do is when you find the x values, you flip them. Flipping them means just putting 1 over and 1 over and finding the right reciprocal functions. So that's it for today, and I'll talk to you tomorrow. Have a good night.